Welcome to support activity 12A, calculating and interpreting z-scores. Data collected by the Centers for Disease Control and Prevention show that the average birth weight for babies in the United States is 7.17 pounds, and the standard deviation of birth weight is 1.3 pounds. What birth weight is one standard deviation above the mean? What birth weight is one standard deviation below the mean? So if I have the mean, so I can take that 7.17, and to go one standard deviation, you will add 1.30, since the standard deviation is 1.30, and you get 8.47. If you want to go below the mean, one standard deviation, so that's you will subtract 1.3 from 7.17, and this is the answer. Number two, we're going to take this value, which we have in number one, and we're going to actually subtract the mean, which is 7.17, and then divide by the standard deviation, which is 1.3. So I'll take the value 8.47 minus the mean, and then we're going to subtract by 1.3. And when I get that, I would have 1. Now I take the other value, which is 5.87, subtract the mean, 7.17, and divide it by 1.3, we'll get -1. In number 3, we're going to have to find that if we go to standard deviation, how far will be of the mean. So if I have 7.17, this is my original mean, and then I will add 2 standard deviation, so 2 of 1.3, so that's will get 9.77 pounds. And if I want to go to standard deviation below the mean, so that means I will subtract 2 of the standard deviation, which is going to end up by 4.57. For each of the 2 answers you computed in question 3. So in question 3 here, we actually subtract the mean 7.17, then we divide by the standard deviation 1.3, or in other words, that we take any value or the value minus the mean, and we divide by the standard deviation. The new calculated value, this is actually, we call it the z-score. So this is whenever we see basic z-score. So remember that we are standardized the value, and we change that regular, this number into that z value. So a z-score measure a value distance from the mean in units of standard deviation. So when we change that to be a z-score, so remember that you may have a positive z-score or negative z-score. So if that positive z-score indicate the value is above the mean, and negative z-score, that means this value is below the mean. So 5, if we try to get what birth weight is 1.5 standard deviation below the mean. In other words, what birth weight has a z-score of -1.5. So if you want to get that, you have to start with the mean. So the mean for this example is 7.17. Then you subtract 1.5 standard deviation. So minus 1.5 times 1.30. So this will give me 5.22. And this is mean basic. This is the birth weight that 1.5 standard deviation below the mean. Number 6, a baby is classified as low birth weight if the weight less than 5.5 pounds. How many standard deviation from the mean is 5.5 pounds? In this case, we need to standardize the 5.5. So we need to find the z-score that corresponding to 5.5. To find z-score, so you follow that same direction. You take the value minus that mean, which is going to be 7.17, and then you divide by the standard deviation, which is 1.3. So I will take 5.5, then minus 7.17, then I divide by 1.3. So my answer is actually comes as negative 1.28, which means that 1.8 standard deviation below the mean. And again, this is obvious, is basic that since that is going to be less than normal, so that's it should be negative, or basic the z-score corresponding to 5.5, it should be negative. The Guinness Book of Records report that the heaviest baby ever recorded weighed a massive 22 pounds. How many standard deviation from the mean is the birth weight? So basic, if you have 22, this is the value. So we're going to take 22 minus the mean, which is 7.17. Then we'll divide by the standard deviation. So that's what I get, which is basic 11.41 standard deviation. And obvious it's above the mean. Number 8 said, in a statistic, you are often interested in finding probabilities involving a normal distribution. These probabilities are calculated by finding the area under a normal curve. So if we try actually to get the area under the normal curve for any normal curve, no matter what, so basic that how that normal curve looks like. And usually the center of the curve is represented by the mean. So the area under the curve must actually cover that all the probability that we could have. And the total probabilities is going to be represented by 100%. That's why the area under the curve, it will always going to be 100%, which is equal to 1. What is the area under the normal curve to the left of the mean? So remember that the mean is the center of the curve. So basic, the area to the right and the area to the left is going to represent half. And basic, that means the area to the left of the mean, or the area to the left to the right, is going to be 50%. Part C, suppose we know that the area to the left of a given z-score is 0.32. What is the area to the right of the score? Again, anytime, whenever you have a standard normal distribution and you have a specific area, which is going to be said that you have a given z-score, that the area to the left, say this is the z-score and the area to the left is 0.32. So again, we know that the total area under the curve is 1, right? Since we know one of them, which is the left area, I can get the right area. We know the total, it must be 1. So basic, if you want to get this area, you're gonna basic that subtract 0.32 from 1, you get the right. So 1 minus 0.32, that answer is gonna be 0.68. And this is basic, the end of this activity, and see you with the next one. Thank you.